complete this one first. Last week we stopped here. Okay, question number, the objective questions. Okay, so we look into the objective questions here. So we look into question number 5. Okay, diagram shows the graph of volume of carbon dioxide gas produced volume against time for the reaction between the calcium carbonate and the sulfuric acid. Okay, so this is the volume, this is the time. So class, the gradient of the graph decreases with time because the concentration of the sulfuric acid decreases because used up already. Okay, so let's say this is your chemical equation. Okay, so calcium carbonate react with the sulfuric acid. Okay, then you produce the calcium sulfate, carbon dioxide, and water. All right. So the gradient decrease, meaning that here you see the gradient will keep decrease and then finally become constant, right? Because the concentration of the sulfuric acid is decreased. In here, constant here meaning that the sulfuric acid is used up already. Okay, so calcium carbonate normally is excess one, no excess. Okay, now. Okay, question number 6. Now, curve 1 in the diagram to obtain when 50 cubic centimeter, 0.1 mole per cubic decimeter hydrochloric acid react with excess zinc granules. Okay, so first, if you are given here, so we can calculate the number of mole first. Okay, so number of mole, we can use the MV over 1000. So M is 0.1, V is 50 over 1000. Okay, so what is your number of mole, class? Okay, you'll get 0.005 mole, right? Okay. Now, okay, so this is for the curve 1. If we want to find the volume, meaning that we can use the mole 0.005 times the molar volume 24. So you will get 0.12 cubic decimeter. If we want to change to cubic centimeter times 1000, so we will get 120 cubic centimeter. Cubic centimeter. Okay, so this is cubic centimeter. So in other words, the volume of the curve 1 you will get here is 120. Okay, 120. Okay, now let's see the question. Yeah, which of the following reactants produce the curve 2? Okay, now curve 2 we see here. Curve 2, we look into the gradient. Gradient is steeper. Okay, so meaning that we have to find a reaction that will increase the rate of reaction. Number 1. Okay, number 2, you see the volume of the gas produced here will be roughly double, right? It's double. So meaning that roughly is 240. So meaning that more we need to find is double also. Okay, meaning that the more is double. Okay, roughly we look like this. We roughly like this. Okay, so now we want to see which one will get the will fulfill the criteria given. Okay, so first, okay, we find the number of mole first. This one MV over 1000. Okay, so we use the MV over 1000. Okay, M is 0.2, V is 20 over 1000. Okay, so what is the value? 0.2 times 20 over 1000. So you get 0.004. Okay, more. In other words, if you want to use this one, the volume you get will be less than the first one. So meaning that this one not possible. Okay, not possible because the mole is less or less. Okay, number 2. Okay, sulfuric acid volume 50, 0.1. Okay, so like this, MV over 1000. Okay, 0.1 times 50 over 1000. Okay, 0.005. Okay, so this one like this, same as set 1. Okay, same as set 1. Okay, let's see, 0.1. Okay, 0.2. This one same concentration. Okay, same concentration. This one also same concentration. Same concentration. Okay, and then this is higher rate of reaction. Okay, so class now, okay, between B and D lah. Okay, we need to choose one. Okay, so that it can fulfill this one. Oh, okay. So you see here, what is a catalyst? Okay, catalyst. So catalyst, it will increase the rate of reaction. Okay, so increase the rate of reaction is correct. Correct. Okay, and then the more is double. Oh, the more is double. So MV over 1000 is 0.1 times 100 over 1000. Okay, so you will get 0.04. Okay, so 0.01 times 24, you will get 0.24 cubic decimeter or 240 cubic centimeter. Yeah, CM3. Okay. So meaning that which one will be taking the curve 2 is the best. So for this one, okay, we will choose this B. Okay, we choose B. Okay, because catalyst increase the rate of reaction, so gradient will be higher. Okay, fulfill. And then more also double. Okay, more also double. Okay, so it's 240 is correct. Oh, okay. And then just now I think for this one, okay, I need to do the correction here. Okay, so for this one, although it's diprotic acid, but here if we do the comparison, sorry, I think we still need to maintain it as a 0.005. Okay, so the volume produced here will be the same. Okay, 0.12 cubic. So it's 120 cubic centimeter. So meaning that B, it will produce the same volume, meaning that same height, but it will react faster, higher react faster. Okay, but it won't produce the higher volume because of this more comparison. Okay, because you need to compare this one. Okay, so the answer is D. Okay, now question number 7. Okay, so you can see the time taken 240, volume is collected, volume of hydrogen gas released or collected is 98.5. So class, what is the average rate of reaction in the third minute? Okay, in the third minute. So class, so third minutes, what is the time range? The time range. Okay, so what is the time range in the third minutes? Meaning that's from anyone know? When is the time range? What is the time range in the third minute? Meaning that from any idea? Darren, Belinda, Ivy. Third minutes meaning that what is the time range? The time range is from second minutes to third minutes, right? So second minutes meaning that from 120 to 180. Okay, so 120 to 180 seconds. Is that okay? So what is the average rate of reaction? So we can use the volume. Okay. So average. So it's the volume divided by the time. So can you calculate it? What is the answer? What is the time? What is your answer? Can anyone calculate? So volume is 95 over, sorry, minus 81 divided by the time. So 180 minus 120. Okay. So use your calculator. 95. Is it A? Yes. Okay. So the answer is A. The answer is A. 0.23 cubic centimeter per second. Okay, what? Pass. So this one looks very simple, but it will come up in the exam. So you have to know how to calculate now. Okay. Now structure questions. Okay. I think we this one. Have you tried this structure question? Haven't, right? Okay. And now I think you try to do these questions, the structure question. I give you 5 minutes. Okay, you try out, see whether you can solve this problem or not. Okay. So everybody, you try. I give you 5 minutes. You try. Okay, class, now we check. Okay, we do it faster tonight. We try to complete the trial question as well. Okay, so first write the chemical equations. Okay, chemical equation. So copper 2 carbonate with hydrochloric acid. So check. Okay, copper 2 carbonate, CuCO3, right? Okay, with hydrochloric acid. So you produce copper 2 chloride as a salt, then carbon dioxide and water. Okay, so it is not balanced, so we need to balance the equation. So this one times 2. Okay, then it is balanced. So 2 marks. All formula correct, 1 mark, and then balancing 1 mark. So 2 marks. Okay. So other than release of the gas, state any observable changes for the reaction. Anything else we can change? We can observe. Okay. What else we can observe beside the gas? Gas is the easiest. We can observe the volume of the gas release. Okay. So what else we can observe beside release of the gas? Any idea? Beside it release the gas? Anyone, you write any answer for this? What happens? What you can see? Okay. The clue is this is the acid is colorless, so we cannot see anything. Okay, but this one, copper 2 carbonate. Okay. So copper 2 carbonate. Okay, what color is this, class? Copper 2 carbonate. What is the color? Anyone know? If you know, you try. What is the color, class? What is the color? Yes. Copper 2 carbonate. What? Ivy? Copper 2 carbonate is a solid, no? It's a solid. This one is a solid powder, huh? So what color is this? There is no gas, no gas. Okay, good try, Ivy. Yes, a green color. This one is a green solid, green color. Solid, no? Okay. Now, and then I ask you, when it react with the hydrochloric acid, it forms a copper 2 chloride, right? Okay, so class, what is the color of this copper 2 chloride? Copper 2 chloride. This one is aqueous solution already, aqueous solution. Because it is soluble salt, no? Soluble salt. So what color is this? Anyone know? Willie? What is the color for this? Linda? Karen? What color is this? Okay. So remember, if aqueous solution, meaning that inside there got the copper 2 ions. Okay. So if copper 2 ions, blue color. Okay, blue color. This one, copper 2 carbonate is solid. So it's special one. Only one copper salt is green color. That is a copper 2 carbonate. Another one is copper 2 oxide. Okay, you can record down. Copper 2 oxide. Okay, this one is black color. Okay, black color. Others like copper 2 sulfate, copper 2 nitrate, that one all are green color. Green color. So in other words, okay. So what else you can observable changes? Okay, so you can write green copper 2 carbonate. Okay, copper 2 carbonate. Okay, dissolve. Okay, dissolve and produce blue solution. Okay. Here you if you want to mention, okay, here you can mention about copper 2 carbonate granules, right? Okay, so you write granules here. Okay. Dissolve in the acid now, meaning they react already. Okay, Okay, C, draw the apparatus step to collect the gas. If you want to collect the gas, so remember, we have to use the water displacement method. No? Okay, water displacement method, how is it? Okay, so this one, I think you have drawn it before. Okay, I just want to show it to you. Okay, so the water displacement method, okay, is this one. Okay. So water displacement method. Okay. Reminders for you. Okay, so first one, stopper cannot fully immerse into the solution, into the conical flask. Okay. Number two, okay, this one, the delivery tube cannot over the water level. Okay. So these two. And then the water must use the dotted line or dotted line to show it is solution. This one also dotted line. Okay. So I think we have done from this diagram before. Okay. So this one you can record, you can draw later if you can get from the notes. Okay, now here on the same axis, sketch the graph for A and set B. Okay, now we look into here. Set A and set B, we look into the condition. Okay, so class, which one higher rate of reaction, class? Set A or set B? Higher rate of reaction. It is. We need to look into what? Okay, look into the concentration. This one, acid, the same acid, right? 0.1, 0.1. Meaning that this one will be the same, So, meaning that hydrochloric acid is not the factor. Okay, now we look into here. This one is the large granules, ketelan besar. Okay. This one is the small granules. So, meaning that this one will be smaller size. Okay. Small. This one higher rate of reaction, higher rate of reaction. So meaning that this one higher rate of reaction, rate of reaction. Okay, so the gradient will be steeper. Okay, number two, we need to see the volume of the gas produced are the same or not. Okay, so this one higher rate now. Okay, now how about the volume? It will produce the carbon dioxide, right? So volume, is it the same? So we look into the mole excess. So meaning that no need to see this one. We will see this one. So we will use the MV over 1000. Is it the same? 0.1 times 50 over 1000. This one 0.1 over 50. So you will get the same, right? Same. So same more, meaning that same volume. Okay, same volume of gas. Yeah, same volume of gas. Because acid used are the same. So meaning that V steeper gradient, then volume of gas will be the same, right? Okay, so this is the one. Okay, so volume of gas, unit stated as cubic centimeter. Then the times seconds. Okay, you see A gradient is lower, and B steeper the gradient, meaning that this one higher rate, higher rate of reaction. Then the volume are the same, volume are the same. Same volume. Again, because the mole is the same. Okay, so 2 marks. Okay, next. Calculate the maximum volume of gas released in this experiment. Okay, in other words, now the question asks you to calculate what is the volume here. Okay, here if we know it, we can calculate the number of mole, MV over 1000. Both experiments are the same. So more is 0.005, no? Okay. MV over 1000, no? Right? Okay, 10 times the mole ratio, mole ratio will be 2 to 1. Okay, why? We look into this one. Okay, see? Here. Okay. So is the acid, no? 2 moles. Then this one 1 moles. 2 to 1, right? The mole ratio is 2 mole to 1 mole, meaning that half, no? Okay. So if 0.005 divided by 2, you get 0.0025. Okay. And then times the molar volume 24, so 0.06 cubic decimeter. So it's 60 cubic centimeter. Okay. If you want to maintain it in cubic decimeter, actually correct also, huh? Correct also. Because the question also not mentioned. Okay. So 3 marks. Okay, now try to do the question number 2. Okay, almost the same. And this one is a very popular questions. Okay. So sulfuric acid react with zinc. Okay, zinc powder. So you see, so sulfuric acid, same, is same concentration? Yes, same concentration. More is the same. And zinc, not mentioned, zinc powder, what would be, we assume it is the same. Okay, but here extra substance T. So class, what do you think is this substance T? And then it will collect the gas in 120 seconds. So this one more volume collected. Okay, more volume collected in shorter time. So if like this, okay, the substance T, if you see others all are the same, so suddenly it will appear extra one thing. So normally this one we will assume, remember it is a catalyst, catalyst. Okay. Now this one also the same. Okay, I give you a few minutes. You try to solve this question. Okay, quickly. Go through. Okay, go through it. Okay, at least you have the idea already, huh? Okay, class. Now we check. Okay, first, suggest the substance substance T. Okay, so here you can see metal with acid. Okay, catalyst used normally we will choose this copper 2 sulfate solution, which is the blue color. Blue color, copper 2 sulfate solution. Okay, so like hydrogen peroxide. Okay, decompose to form the water and oxygen. This one. Okay, so this one, the catalyst used is the manganese 4 oxide. Okay, so basically you will see, okay, the experiments that will be asked in the exam. Okay, so whether it's acid with metal, copper 2 sulfate solution. This hydrogen peroxide is manganese 4 oxide. Normally it's these two. Okay, so what is the function? So as the catalyst, as a catalyst. A very simple answer. So write a balanced chemical equation for this reaction. So zinc with sulfuric acid. So it forms the zinc, sulfate, and hydrogen gas. So again, if you want to calculate the rate of reaction, so we will collect the hydrogen gas. Okay, hydrogen gas per unit time using the water displacement method. So now compare the rate of reaction between set 1 and set 2. Set 1 and set 2, not set 1 and set 1, set 1 and set 2. Okay, set 1 and set 2. So class, which one has a higher rate of reaction? The one with the catalyst, right? So set 2 has a higher rate of reaction than set 1. Okay, our collision theory. Okay, so class, for this one, we do some revision. Sulfuric acid with excess zinc. So what is the particles that collide? The particles, because in the collision theory, we need to mention what is the particles that will collide. So acid, what is the particles, class? Acid. What is the particles? Still remember? For acid, will be hydrogen ions. Okay, hydrogen ions. Okay. Then how about zinc? Zinc is the metal, so it will be zinc atoms. Okay. So these two will collide with each other. So in the collision theory, so your particles, you have to mention these two, remember. Okay. So based on the collision theory, the catalyst, right? Okay. Catalyst provides alternative pathway with a lower activation energy. Okay. So catalyst lowers the activation energy. So this is point number 1. Okay. So frequency of collisions between, again, you see hydrogen ions and zinc atoms. Okay. So frequency of effective collision increase. Okay, effective collision increase. Okay. So higher rate of reaction. So this one, collision between the particles, hydrogen ions, and zinc atoms. Okay. So number 3, frequency of effective collision increase. Okay, and higher rate of reaction. Okay. So normally this one will be 3 marks, not until 4 marks. Okay, and now done already, this one, the collision theory. Okay, so now construct a energy profile diagrams. Okay, this one I would like you to pay attention. Energy profile diagrams. So sometimes the question will ask you to draw or construct the energy profile diagrams. Okay, to show the activation energy without catalyst. Without catalyst will be EA, and then with catalyst will be EA prime. EA prime got extra prime here. So it is the activation energy. Okay, So without catalyst, so original one, okay. So let's say this is the hydrogen ions, so H plus, okay. With zinc, so that then this one like energy profile diagram, it has activation energy, so it go up and then go down again. Okay, huh? Like this. So the activation energy without catalyst is the original one. So this one is a EA. Okay, so this one it must be exactly touch the line here. Yeah, okay. And then this one for me, it won't be so correct now, not that accurate. The best, you also can use a ruler, draw a line, and then you also draw like this would be the best. Okay, if like this, maybe it is not the peak here. Okay, so this one is the EA prime, meaning that this one with catalyst, which is lower. Okay, which is lower. Oh, and then this is ionic equation. And then if you want, you can draw you can use the chemical equation also can. Okay, so accept chemical equation. Okay, and then this one must label energy. Must label energy. Okay, this one still okay. Reaction pathway still okay. Okay, huh, class? So this one you learn how to draw it correctly, huh? This is called energy profile diagrams. Okay, I think in your final exam, okay, Form 4 final exam, I think your teacher will ask you to draw this. So you must know how to draw it, okay, correctly. So normally it's 2 marks or 3 marks. Okay, ready? Okay, huh? Now we look into the essay questions. Okay, this one we discuss directly. Study the statement below. Okay, the rate of reaction is important. List 2 changes that can be used to determine the rate of reaction. Okay, so the first one will be the formation of the gas. All right. Okay, formation of the gas using the water displacement method. Okay, volume of gas. Number 2 is the mass of the precipitate form. Okay, it will form the precipitate. Okay, two most popular. Again, most popular method for us to calculate the rate of reaction. So normally volume of gas released, okay, will be factor of size and catalyst. Okay. Then for mass of the precipitate, there is the sulfur. The factor is the concentration, and then the temperature. Okay. So these 4 experiment will be done in school. Okay. And number 2, let's see. Okay, Haber process is one of the example industrial process to manufacture the ammonia. So what is the condition required for the production of ammonia? Okay, so here the condition here normally will refer to what? To temperature, catalyst, and then the pressure also. Okay, so remember for this Haber process, okay, so the catalyst used is iron. Okay, temperature is 450 degrees Celsius. Pressure is 200 atmospheric pressure. Okay, so this is for Haber process. To produce ammonia. So record down. Okay, next we look into next question. Okay, this investigate the effect of one factor. Not mention what factor is it. So this is zinc carbonate chips. Okay, so you have to see the words chips here, and it is sulfuric acid. Okay, set 1. Okay, then the concentration 0.2. Okay, now Sec2, sulfuric acid, same acid, right? Okay, no problem. Here, I think you know already lah. What is the factor now? Plus the others all are same, right? So the factor now will be the size, right? The size. Okay, that is the total surface area. Okay, powder will be bigger total surface area. Okay. So Sec1 and Sec2, we know that Sec2 higher rate now. So Sec2 higher rate. Okay. So this is the first thing when you look into the question, you know how to solve the question already, huh? Okay. Now the volume of the gas released Sec1 and Sec2, you see. Okay. So volume are the same. Okay. But which one will complete faster, class? You see here, Sec1 here 210. This constant, meaning that this one complete. But for Sec2, this one complete faster. So at 150 degrees, 150 seconds already completed. Okay. So class, calculate the average rate of reaction for this Sec1 and Sec2. So class, how to do this? Is the volume divided by the time. Volume divided by the time. Okay. So for Sec1 and Sec2, meaning that you have to calculate for both. So Sec1, what is the time taken? Remember, don't use 240. We don't use, because this one already stopped. So meaning that volume 32 divided by 210 for Sec1. Sec2 even faster compared to Sec1, because at 150 seconds already constant after that. And so the time is 150 seconds. So you calculate. See? Sec1 32 over 210, so 0.15. Okay. Sec2 150, you can see. Finished already, completed already, so 0.21. Meaning that Sec2 higher rate of reaction. Okay, unit must be stated correctly also, unit. The unit, cubic centimeter per seconds. Okay, volume divided by time. Okay, now sketch the volume of gas released against time for Sec1 and Sec2 on the same axis. Okay, so on the same axis, a lot of students don't know what is the meaning. Meaning that Sec1 and Sec2 you draw at same graph. Okay, so here we roughly know already, Sec1 and Sec2. So this one completed later, this one faster, correct? 150, meaning that you can sketch. So Sec2, let's say 150 already stopped. 150. But Sec2, sorry, Sec1, Sec1 roughly is 210, only is stopped. Okay, so cubic centimeter, time is second. So all this need to mention. Okay. Next. Okay, so this one calculation, calculation. Okay, so compare a maximum volume of gas release from the experiment. So compare the value to the actual value. Okay, explain your answer. Okay, so first we need to calculate the volume of gas release, theoretical one. So we calculate the number of mole, mass over molar mass. Okay, because the acid now is sulfuric acid is excess, because in the question mentioned. So this one is excess. So no need to calculate this one. We will calculate for this one. Okay. So mole is 0.016, 0.0016. Okay. And carbon dioxide ratio is 1:1. Okay, 1:1. So meaning that mole will be the same. Okay, one more, this one more. So it'll be the same. So if you have the mole already times 24, molar volume is 38.4 cubic centimeter. Okay, not 3A, 3 only. 3. cubic centimeter. Okay. So the theoretical should be 38.4 cubic centimeter, but in the exam, only 32. Practically from the graph, only 32. Okay, why? Okay, the actual volume of the gas released is lower than the calculated value, because small amount of the carbon dioxide gas is dissolved in water. Okay, because some volume of the carbon dioxide is dissolved in water already. Okay, it is soluble in water. So remember that answer. Okay, so theoretical should be this one, but from the graph here, only 32, right? Only 32. Why? Some carbon dioxide gas release dissolve in the water. Okay. So it dissolves in water to form what? To form the carbonic acid now. It forms the acids. Okay, weak acid now. Okay. Okay. So last question. The collision theory. No? Set 2 we know is higher rate of reaction. So first we mentioned rate of reaction set 2 is higher. Okay. Because the size of the zinc carbonate is smaller in the powder form. Okay. So the smaller the size of the zinc carbonate, the larger the total surface area exposed for the reaction. So frequency of collisions between, okay, you see here, zinc carbonate, okay, here, this one wrong, not molecules. No need to mention zinc carbonate enough. And hydrogen ion, so E. Yeah, zinc carbonates and hydrogen ions. Okay. So point number 4, higher the frequency of effective collisions. Okay, so point 3 and point 4, the difference is effective collision and collisions. This one, effective collisions. The remaining are the same. Okay, this we discussed already in our previous lessons. Okay, so the questions that we discussed just now, they are very popular in the exam. So you have to know how to answer them correctly. Okay, so remember you have to read again. Do the revision. Do the revision. Okay, finish already? Finish? Really? Already? Suyang? Okay, done. Okay. If already, now we can done. Okay. Now we go to the trial questions that I say we will discuss tonight. Okay. And then you will see the more questions that we try, actually you'll see the pattern almost the same. Okay. And then you will see it is keep repeating the question actually. Okay, let's try the question, the chapter 7, the trial questions. Hold on, let me question number 7. Chapter 7, Okay. Okay, so first one is the Malacca, right? Malacca questions. Okay. So this one I would like you to try first, the structure question. So first we I give you a few minutes. You try first this question, Malacca. Okay, Malacca 1, 2, 3, 4, 5, 6. 6 marks on me. Be quite fast, Okay, class, done already. Okay. We discuss, okay, if you haven't complete. Okay. So diagram shows graph of volume, okay, release against time for calcium carbonate and the hydrochloric acid. So you see 22, 38, 45. Okay, here's the time. The time. Okay, now is the question. So state the meaning of rate of reaction. Rate of reaction. So here we see is a volume of gas released over the time. The change or increase in the volume of carbon dioxide collected per unit time. Okay. Number two, state one observable changes in this experiment that can be used to determine the rate of reaction. So here we know already the volume of gas collected, right? So you will release the gas. Is it carbon dioxide? Yes, carbon dioxide gas. Gas released will be carbon dioxide. Okay. So use the water displacement method. So calculate the overall rate of reaction. Okay. So overall rate of reaction, don't use the overall time. We need to see what is the reaction completed, meaning that it become constant already. So it's 240, 45 over 240. So 0.188 cubic centimeter per second. Okay, class, correct or not? Is that correct? Based on what you have calculated? Correct or not? Okay, good. So 2 marks. Okay, now next, classify the following into fast reaction and slow reaction. So which one is fast reaction, class? Okay, so first one, electric cell reaction. Okay, this one fast or slow, class? The first one, fast or slow? Fast, fast. Number two, fireworks. During the Chinese New Year, a lot of fireworks. That reaction is fast or slow? Fast or slow, rock erosion. This one I think we know already. Very slow, right? Fermentation, fast or slow? Slow, yes. Okay. So 2 marks. Okay. Very simple, This one, fast and slow reaction. Okay, next. This one, another one. Okay. 2 set of experiments. The effect of affecting the rate of reaction between the hydrochloric acid and zinc carbonate. You see, if not metal, it is a carbonate or calcium carbonate or zinc carbonate. Okay, or calcium carbonate. This one should be not calcium. I think it should be zinc carbonate. You see, this is the reality. Sometimes in the exam, they just change zinc carbonate or calcium carbonate. Will be the same. Always using the same. Okay. So this one, you see, chips. This one also chips. So size, no problem, no, it will be the same. And then concentration, let's see. This one 0.25 mole per cubic decimeter, 0.5. So acid the same. So meaning that now the factor will be the concentration factor, right? And then volume of gas collected will be more. So class, which one higher rate of reaction? Set 1 or set 2? Should be set 2, right? Set 2 because higher concentration, right? So you try to answer the questions. Okay, so also very fast one. Okay, I will let you try first. Okay, otherwise we just discuss and then you haven't think, then you won't get a better understanding or you cannot remember. Okay, I'll let you try first. Okay, class. Now we check. So state one factor that affects the rate of reaction from the diagrams. So we discussed already, is the concentration, right? Okay, so what is the reading needed to be recorded in both experiments to determine the rate of reaction in the 3 minutes? Okay, so volume of the carbon dioxide gas. No? Okay. Number C, write the chemical equation for the reaction. So zinc carbonate with hydrochloric acid produce the zinc chloride, carbon dioxide, and water. So you need to balance the equation, no? Okay, average rate of reaction in step 1. So volume divided by time. So 60 cubic centimeter per 1/180 seconds. So 0.33 cubic centimeter per second. Correct on that, class? Is that correct? Okay, next. Finish already, class? Okay, compare the rate of reaction in set 1 and set 2. Explain your answer in referring to the collision theory. So 3 marks. So set 1, set 2 higher rate, all right? Set 2 higher rate of reaction than set 1. Okay. Then the concentration, right? Okay, the concentration of hydrochloric acid in set 2 is higher. So the number of hydrogen ions per unit volume is higher. Okay. So actually, you need to mention about the collisions. Should be more. This one more to like essay questions for me. So it should be 4 to 5 marks. Because here it will be until number of hydrogen ions. So you have to mention about the collisions between the hydrogen ions and zinc carbonate, right? Zinc carbonate increase. Then frequency of effective collisions increase also. Then higher rate of reaction. Okay. Now F. Okay, a student wish to increase the rate of reaction for set 1 by changing the hydrochloric acid to sulfuric acid of the same concentration. In your opinion, do you think that he makes a correct decision? Okay. Yes or no, class? The student wish to increase the rate of reaction. What is the answer? Yes or no? Okay, yes. Wen-Xin mentioned is yes. Okay, why? Explain your answer. Hydrochloric acid, same concentration. And the answer is yes or no? Correct, Okay. Because the sulfuric acid is diprotic acid. So the concentration of hydrogen ions in the sulfuric acid is double compared to the hydrochloric acid. So the rate of reaction is higher. Okay, done already, class? Okay, and now we look into this question. Question number 7 is structured question again, I see. Okay, 2 sets of experiments to investigate the factor affecting the rate of reaction. Okay, you see, again, same chemicals. Calcium carbonate, this now is zinc carbonate. But it's still the same. You will produce a carbon dioxide gas. So let's see set 1, set 2. This one, the time taken, 33:45. Meaning that this one higher rate, rate of reaction. Okay, why? Let's see. This one is calcium carbonate powder. Here powder. See, this one is powder, not here. No, this is chips. And concentration 1. This one also 1. So same concentration. Acid the same. Okay. So meaning that now the factor is the size. Okay, the size or total surface area. Okay, and now you try this one. Quickly answer these questions. Okay, so class, now check. Okay, first write an ionic equation for this reaction, for the reaction in this experiment. So ionic equation, so acid will be hydrogen ions, calcium carbonate will be maintained in the solid form. So it forms the calcium ions and then carbon dioxide and water. So this is the ionic equation. So class, later the collision will be between the hydrogen ions and calcium carbonate. Calcium carbonate. So the particles. Okay. So compare the rate of reaction for set 1 and set 2. So set 1 is higher than set 2. Rate of reaction. So rate, use the higher. Don't use faster. Okay. Explain your answer. Refer to the collision theory. So the size of calcium carbonate in set 1 is smaller than set 2. So total surface area exposed for collision of calcium carbonate in set 1 is larger than set 2. And frequency of collisions between the calcium carbonate and hydrogen ions in set 1 is higher than set 2. Okay. And point number 4 will be effective collision. The effective collision. Okay. You follow the one we discussed last week now. That one will be the perfect one. Okay. You always can refer, Can refer to the notes last week one, Okay. Next, sketch a graph, volume of carbon dioxide gas against the time. Okay, set 1, set 2. So set 1 higher rate, right? Steeper gradient, okay. But here we just stop at 40 cubic centimeter, because the question only mentioned about the 40. So this one faster, okay, faster, shorter the time means higher the rate. Okay, this one longer the time, so lower the rate. Okay. But at the end, actually we still don't know they will have the same mole or not. Okay. Any question for this graph? Because we just focus to 40 until 40, because given in the table. Given in the table. Okay, Now, I think this one's almost the same, Same questions here. So yes, the number of hydrogen ions is double in sulfuric acid. The same question as well. Okay. So this one, okay. So in 1 minute, 30, this one 50. So this one collect more gas, Okay, let's see. Concentration, the same. Yes, powder, the same. Okay, yes, catalyst S. So plus, what is the catalyst? Just how we mentioned already. How about this? Just now, the question is anyone still remember? The catalyst. Yeah, copper 2 sulfate solution, so remember. Okay, and then okay, I think you also try to answer the questions first. Okay. Now we check for the following questions. Okay, state the name of the gas release in both experiments. So it must give the name, don't use formula. So it'll be hydrogen gas. Okay, C, calculate the average rate of reaction in the unit of, you have to follow this unit, volume divided by time. Okay, so 30/60, so 0.50 cubic centimeter per second for sec 1. And how about sec 2? Let's now check. 50/60, so 0.83 cubic centimeter per second. So meaning that this one, sec 2, higher rate, rate of reaction. Okay, higher rate of reaction for sec 2. Okay, so far correct? Excuse me. So compare the rate of reaction in the sec 1 and sec 2. So sec 2 has a higher rate, right, than sec 1. Okay. Explain the answer based on the collision theory. So catalyst lowers the activation energy in sec 2. Okay. So more colliding particles can overcome the activation energy. Okay. Now, more frequency of effective collisions between what, zinc atom and hydrogen ions. So you have to mention this correctly. Don't use particles. Okay. Here, particles is okay because here you mentioned already. In your explanation, you have to at least mention one time what is the particles. Okay. Let's say here you mention about zinc atom and hydrogen ions. Let's say in point number 2 here. Then here you can use the particles. Should be okay. Oh. So in your explanation, at least you mention one time already. Okay. Don't just write particles. That one you cannot score the full marks. Okay. Again, energy profile diagrams again. So make sure that you know how to draw this correctly. So in the exam, so show the activation energy for sec 1 and sec 2. So sec 2 has a higher has a catalyst, right? Okay. So here, see, this one better. This one better. So sec zinc and nitric acid. No, okay, here. So you see, okay, the activation energy original this one. Sec 1 without catalyst, no catalyst. Okay. So from the reactants to the peak. Okay. Now for the sec 2, okay, EN prime. Normally we will use the prime, E prime. So sec 2 catalyst. So it lowers the activation energy. Okay. Energy level. Okay. Then the reactants and the products, all these. Okay. You can also use the ionic equation. No problem. Okay. So this one you have to label correctly. Is lower. It's lower. Okay. Any question? No question, no? So make sure that you know how to draw it correctly, Okay. Now, question for Kedah. Okay, again, you see hydrochloric acid with zinc metal, Okay, so acid with metal, so produce a hydrogen gas, Okay, again, still is gas. So based on the diagrams, what is the meaning of rate of reaction? So the volume of gas collected over the time, right? Okay, change in the quantity. Okay, so quantity, you choose to volume of hydrogen gas produced over time. Okay. So don't use quantity, we use volume of hydrogen gas. Okay. Volume of hydrogen gas produced over the time. Okay, Next, state the observation. So effervescence occur or bubble gas produced. So in exam, you try to learn how to use this word. Okay. Effervescence or bubble gas. Write the balanced chemical equation. Okay. So make sure it's okay. Right. The experiment is repeated by sulfuric acid to replace the hydrochloric acid. Predict the rate of reaction. So the rate of reaction is higher, will be increased. It will be increased. Okay, why? Because sulfuric acid is the diprotic acid, right? Okay, now this one. Okay, the overall rate of reaction for this experiment class. So what is the time for the reaction to be completed class? So the is a volume divided by time, right? So the time should be, is it 300? No, no, should be 240, because after that, no change. Okay. So for 45.3 divided by 240, so 0.18 or 19, if you want to round off, to be 0.19 cubic centimeter per second. Okay. Now, average rate of reaction in the third minute. So in the third minute, what is the time range, class? 10 minutes to third minutes, all right? Okay, so meaning that from 120 to 180. So the volume here, okay? So 40.1 divide minus 30.9 divide by over the time 180 minus 120. So 0.1533. Okay, cubic centimeter per second. Okay, hot class. Okay, now in a community cooking event, Rizal has assigned to 8 potatoes as one of the main ingredient in the food. Explain how he could cook the potatoes quickly and state the factor involved. Class. How he can cook the potatoes quickly, class? And then the factor? What do you think, class? Cut the potatoes into smaller size. Yes, very good. Okay, factor, another one, you can use here will be factor of pressure also can, okay, or size, but we you can choose either one. Okay, the factor, this one is more common now. We use smaller size. Cut the potato into smaller piece to increase the total surface area, so more heat is absorbed. Okay, so this is the first choice. The second choice, actually, we can use a factor of pressure. Okay, you can choose any one. So we can use the pressure cooker. So pressure inside the pressure cooker is higher because the cooking is done at a much higher temperature. So, okay, so if the higher temperature, higher pressure, the temperature will be higher also. So it can cook faster under pressure factor. Okay, but these are more common now, size. Okay, you can choose any one of these. Okay, huh? Okay, so I think we stop here tonight. Okay, thank you for your attention. Okay, and good night to all of you.